what we're happy with as a profession, and whether we're okay to sit on our laurels or whether we want to keep pushing the boundaries of what we can do in our field. Show of hands, who in here on a daily basis is working with Idris, Agda, something like that? Good, so everyone in the room, everyone here in some form or another is working full-time on some sort of, I'm going to assume Idris for now, and please be okay with that, code base. We can see Stack Overflow being as good a measure as any. Idris at this point is by far the most popular language, and I think that comes from a number of things. I think first and foremost, its insistence on pushing towards programming for the web, programming for backends, programming for native applications. It's really kind of spread over the full set of domains that we're interested in. You can also see Haskell up there as kind of, woven in and out. We'll talk about Haskell a bit later. It's a slightly more academic language, but I'm hoping we can build to that, and by the end, as I talk about the state of the art, which for the purpose of this talk is JavaScript, we're all going to feel a bit more comfortable with some ideas that, I'll be honest, will make you uncomfortable, right? We are going to see some ideas that we're not used to, and I want us to be okay with that. This is a safe area. If you have any questions, please do shout out. The perspective I'm going to take, simply because I think JavaScript is such an interesting research language, is to focus in on the type system of JavaScript. I don't think in the time I have I can really explore the full set of features, so that's what I'm going to pin down. And so we'll start for your benefit with something that we're all very comfortable with, which is dependent types, especially in their Idris form. In case anyone in the room isn't an engineer by trade or hasn't done a boot camp or whatever, we're going to start with the kind of two-slide explanation of what dependent types are. So I'm going to use this wall. I didn't know there'd be two walls, so sorry for everyone on that side. This is a function called typeOf. It takes a thing of type T and returns a type. It does that by completely ignoring the argument, but pulling the type down from upstairs and just returning that instead. Right? So this is not weird to any of us. We're all used to seeing this sort of notation. This kind of illustrates that there's really no difference between this line and this line. If I want something and it happens to be there, I can just pull it down and carry on. And indeed, this works as you might expect. For simplicity's sake, I've mentioned the language we're working in the top right, just to keep track of that. But we can see type of 3 is integer, type of hello is string, type of null. I should introduce that as a point of terminology. Unit in JavaScript is called null. We will come back to this later. And the other function that I think demonstrates it quite neatly, I'll swap sides and then you'll both get a bit, is the function the, which says, give me a value t of type, a thing of type t, and I'll give you a thing of type t. So what's weird here is we've pulled something from downstairs up, and we've said, you're going to pass me a type, and I'm going to use that to determine the type of the argument that then follows. As we all know, another way of putting that is the type of the result depends on the value here. And as we might expect, we've got this kind of the int3, the nat3, the double3. Depending on the type we pass in, we get a different type out, right? So this is dependent types, the dependent types we're all familiar with in our day jobs. So the first point of discomfort I want to talk about is another problem that we're all too familiar with as software engineers. Anyone who's ever tried to install something on an operating system, anyone who's ever tried to deploy microservices, more on that later, knows that there's an implicit hell that comes with anything involving dependency management. Versioning and this sort of thing, and making sure that the things I need are provisioned and ready at the time I need them. And so I think the first really significant question JavaScript asks is, if none of us like dependencies, why do we want them in our types? Why have dependent types? Has anyone ever given a thought of what independent types would look like? Has anyone even questioned whether we need types? And JavaScript has a slightly novel approach to this, which I've coined agile types. Thank you. And what JavaScript says is types are free-flowing. They'll change throughout the life of a program. They'll iterate. They'll grow. They'll approach what we want, but we don't have to make those decisions up front. I'm sure I'm not the only engineer whose project has gone off the rails because we made a decision on day one, and we're then stuck with it forever. And I think JavaScript kind of promotes that idea to the type level and says, let's just wait. Let's just see what happens. So it turns out the right-hand side, sorry, this screen this time. The right-hand side here is the JavaScript type system. I'm sorry if this is unfamiliar or scary. This is valid Idris 2 code. What we're saying is if you pass me a thing, I'll ignore it, but I'll take its type. And then if that type's a string, in JavaScript we call those strings. If it's an int, double, nat, float, I missed some of them out, we call them numbers. If it's a bool, it's a boolean. And if it's literally anything else, it's object. I've omitted undefined, which also has a thing, but we're not going to talk about that until we get onto Haskell. So actually, believe it or not, this is a JavaScript REPL. This isn't Idris. This is me using that function in JavaScript. It's actually a primitive in the language. It's that useful. The thing I want to draw attention to here is kind of obviously JavaScript is an early stage academic language. It hasn't had the same kind of input in usability as maybe languages like Idris or Agda have had. And I think on the whole, it does a pretty good job, but you'll have to forgive things like the quotes being different colors. It's early days. We will get to it. So the next uncomfortable thing that I want to raise with you is this notion of a single source of truth. Again, to return to microservices. One of the things we think is a good idea when we start developing an application is this notion of, if I have an intrinsic fact, I want it to be in one place. And then if that's the canonical source of this information, nothing can go wrong. Except we then have 50 microservices, and this is now a liability. Having a single source of truth is a danger in our applications. And so JavaScript says, what if we approach that problem but phrase it in terms of types? So I'm just going to get some. So in Idris, we only really have one way of telling the truth, and it's this type here. And that's fine, but let me pose a problem to you. Let's say, as part of your convoluted application, you have to check that a talk is being attended by at least one person. So as part of your business logic, you say, if the length of attendees is over 1, then do this. Fine. But what happens when the microservice that has to check Boolean predicates goes down? We're stuck, right? And so JavaScript says there are many forms of truth. We're not limited to false and true. And actually, there are a wealth of values that we can understand as having some sort of truth to them. And again, we can sort of model this in the Idris that we understand with this interface that I call bool-ish. Again, it's not ideal because the limitation of Idris's design is I have to convert back to a bool, which obviously puts us in the same situation. But JavaScript, again, has thought of this problem and baked it in. So we find this screen. Bools are very boolish. That's just normal. Null is always false. Integers, nats, doubles, whatever. As long as it's not 0, it's true. And strings, as long as they're not empty, they are true. And this actually gives rise to, I think, something that Idris has really missed, which is we've unnecessarily monomorphized a lot of our basic operations. And the one I want to look at is the double ampersand operator. So in Idris, we have this weird restriction that both of the things on either side not only have to be the same type, but have to be bool. And actually, if we take a leaf out of JavaScript's book, that's not strictly true. And luckily, we do have the language in Idris to kind of give this, I feel, the type it deserves. So what we're saying here is give me a value x of type A, give me a value y of type B, And if it turns out to be true that X, then the return type is B. Otherwise, it's A. So that's cool, right? And then down here at the value level, the peasant level, we do the same thing, and we match. This is a dependent pattern match, again, for the product owners in the room. This is when I want to do something but kind of share the information upstairs. I use this with syntax, and that makes everything happy. And indeed, now, we get, I think, a much more intuitive behavior. So this is not only Idris, but this is also valid JavaScript for people who've never seen JavaScript before. This does indeed work and compile. And yeah, there you go. There's proof. Again, sorry about the quotes. We're looking into it. One of the things I think JavaScript does a pretty good job of is avoiding this problem, which is to say, this highlighted bit at the moment says, if X is truthy, then B, else A. And this bit down here says, if X is truthy, then it's the Y, which is B, else the X, which is A. And I think an important property we've forgotten as software engineers is that repetition is useless, right? Let's be frank. Only one of these two is delivering business value. We don't need both. And I want you to bear that in mind as we go through the next few examples. So we've seen a couple of primitives of JavaScript. So as not to scare you, I want to frame the rest of the talk in the context of this library, Ramda, which, if you don't know, is kind of academia's attempt to make JavaScript more approachable by trying to frame some of the Idris functions that we would understand in a way that works in JavaScript, right? You can think of it as a kind of bridging library from one to the other. So as a quick example, we'll start off. No, this isn't a kind signature. This is a function that says, give me a number of types, ... that return an A. So that's a function. It's not too weird. Then give me those types as a list, and I'll give you an A. So a bit weird, right? Again, Idris imposes this idea that not only do I have to know how many arguments I have up front, but I have to know what they are. And that's not true in an agile workplace. But we can see down here, math.max is a strictly 7-argument function, which takes these 7 arguments and returns the biggest. So how might we, as everyday Idris developers, kind of parse this and understand it and build an intuition for how this mystical language is working? And I would start by writing a type. So this is a function, believe it or not, and this takes let's just say a list of types for argument's sake, and a type, and returns a type. And in practice, this is a list of the arguments and the output type. If we have no arguments, we've got the output. If we have some arguments, what we want is a function from the first input to the rest, right? This is the recursion we all know and love, except there's a function arrow, which is pretty rad. So the type of apply, then, in our understanding, says, give me a heterogeneous vector of the input variables, and then pass the list of types of those inputs to that function along with the output, and I'll return the output. So JavaScript, I think, introduces an interesting way of looking at functions, which is traditionally in Idris, we think about functions as being read from left to right. And what JavaScript lets us do is sort of read it from the middle to the end and then back to the beginning to figure out what the first argument was all along. And again, I think in a world of kind of distributed systems, having that more fluid understanding of when I will gain information is an incredibly powerful paradigm to be working in. And of course, down at the business level, we actually have a fairly straightforward function. We're just saying, give me the argument, apply it, and then carry on. Everyone following so far, haven't scared anyone. We're all comfortable. It's still Idris. Good. So here again is some Idris and JavaScript. So I can apply either a list of things, or I can apply a list, and then I'll get back another function, and I can give it the remaining argument. Great. So the next thing I want to talk about is ADTs. So ADTs stands for one of two things, depending on which blog post you read. It either stands for abstract data types or algebraic data types. And JavaScript made this decision early on to say, abstract things aren't useful, and algebraic things only work in papers, right? In the real world, neither of these concepts are productive. So what if we just use lists for everything, right? No one can laugh at that joke, because that's what Lisp did. Like, that's serious. So let's take case statements, and let's see what they would look like if we removed some of the restrictions. So I think I'm on this screen now. We have this cond function says, give me a list of predicates, and give me a list of pairs of predicates and functions, and I'll call the function that matches the predicate, right? All straightforward. So down here, we say the function is conditional. If the value you give me equals 0, I will return water freezes at 0, 100, water boils at 100, and otherwise, so t means otherwise, I'll give you this function that says, give me the number you said, and I'll say nothing special happens at that. So this is, again, this might look a bit weird, but I think actually when we translate it back to Idris, a lot of the beautiful symmetry kind of emerges. So the first thing we're going to need is a list. And all the lists we've had ever aren't good enough. So let's pick a different one. So important thing to remember about this is it takes a list of pairs, and Idris famously doesn't have a pair type. So we have to model it with this h-vect of an a to b and an a to c. And what we're saying is you'll give me a pair of functions. The first one takes some a to a Boolish value. Doesn't have to be bool, distributed systems. And another function that takes the same a and returns a result. And then this is kind of like the tail of the list, right? So this is head, tail, makes this list. So I just add the result type to my list of conditions. The next thing I'm going to need is a sneaky helper function, which says, given a function type, tell me what the type of the result is. So this is like what we saw at the beginning, except a little more obfuscated. And then finally, we say, OK, well, if there are no conditions, the answer is null. That's what the first line says. The second line says, if there is a condition, and that evaluates with x to true, then the result is, or sorry, the type of the result is the result of that g. And otherwise, we just loop through. Recursion, all fine. Just happens to be at the type level. Down at the business level again, we get back to the useful function, which says, give me some conditions of value, and I'll give you the answer. How do we do that? It's null if we don't have any conditions. If we do have conditions, if the head matches, then we call g with a, all fine. And if it doesn't, we carry on down the list. It's recursion, but 3 times. Don't repeat yourself. So here's some Idris and JavaScript. Works equally well in both. So sorry, other board. So we pass 3 to this condition, and it says if it's greater than 2, return ID. So we get 3, which is a nat. But if we change this to greater than 3 and pass 3, it's not greater than 3, but 3 is a truthy value. So we always get hello. And indeed, we have hello that's a string. And if I take out that one, we get null. Right? So hopefully at this point, we're getting comfortable with JavaScript, with the way it works, and we're not. Is anyone deeply unsettled by what they're seeing? Good. Good. Well, let's get to it. So converge is another JavaScript function, which personally I think should be a primitive at this point. It's so incredibly useful. And what it does is say, if you can give me a function like divide, which takes 2 arguments, and a list of 2 functions, when you give me an input, I'll apply it to those functions, and their results will become their arguments. So if that's horrifying, what we're saying is, give me this list, and then figure out the sum and the length, and then divide the sum by the length. So if you think about it in like a flowchart, it kind of goes out and then comes back in, right? We're saying this is a function that needs 2 versions of this list, depending on what the others produce. And down here, we say concatenate the uppercase and the lowercase version of this string yodel, and we get this. Pretty useful. So we're going to need a different type of list. This is going to become a recurring theme. So the lists we've seen so far are rubbish, completely unhelpful. What we need is a list of functions. All of them are going to have the same input, but they're all going to have different outputs, which is very important because they all need to produce different values for our function. And then converge actually ends up being this beautiful little number, which says if I have no things to converge, I'm done. And if I do, I apply that g at the head to the x, and that's my first argument. So for each of those functions, I apply it to the input value and pass it to f. And that's it, which I think, JavaScript is getting a bad reputation. I think actually it can be quite concise. And again, here's an example in Idris and JavaScript. I've been unfair here. What we're saying is basically those examples we saw. I can pass in divide, a list of functions, and I'll get out the answers I expect. So we come to my favorite feature of Ramda, with time to spare, good, because this is a long one. Curry is a function that we'll soon see is not something Idris is capable of expressing. Currying is a concept too advanced, and we'll have to pick another language, but don't worry. On paper, it seems quite clear that we take a thing of kind type and an a and a thing of, but that's not what this says. What this says is give me a function, and then using any elaborate combination of tuples, as long as the number of things you end up giving me add up to the number I was expecting, this function will work. Brilliant. So we run into a problem with Idris, and for those mid-level senior engineers in the room, the problem is decidable equality on types. Idris has made this, in my opinion, terrible decision that you can't, in Idris, have decidable equality on types. And the reason is because you can't. It's an understandable decision, given that it's strictly impossible to do. But JavaScript isn't deterred by such things. So how are we going to solve this? We are going to need a language more capable than Idris, with a more advanced type system. And people may have heard of Haskell. It's a little more niche than Idris. So here's a type family that explains what currying should do. So if I have a function from A to B, and I give you no arguments, just carry on. This is fine. Just curry the rest of it. If I have a thing that isn't a function and I give it no arguments, we're done. If I give you more than one argument and I've got a thing, the result is going to be a function that is kind of the first argument to the rest. Similarly, if it's not more than one argument, I say it's a function from that argument to currying the rest. And at last, we say if it's none of these things, it's just an input and an output in a plain old Idris function. So you can think of it, if you like, as saying that Idris is literally only capable of the bottom line of these 5 equations. So something we may not be familiar with, because in Idris we're used to the interface syntax. This is called a type class. It might be class, I've never been sure. What we do is we take the shape of the function and the output we want it to produce, and based on those, we'll do terrible things. So first case is pretty straightforward, right? We just ignore the argument and carry on. Second case gets a bit hairier. So we have this input, but we're just returning the thing. So it's not a million miles away. We just don't curry afterwards. A third case, I've got 2 arguments, so I'm just going to pass the first and then curry the result. Recursion. We're all OK. So when we get down to case number 4, we have to start doing some tricks. At the type level, I want to reiterate, value level is sort of fine, right? And I think this is a JavaScript talk. We should stay down there and ignore the ivory tower above it and just say what we're going to do is we're going to take f and x. We're going to apply x to f and curry it. And then finally, we've got this nice little one. ID is a function we all know and love. Thought that was a nice place to end before I scare anyone. So this is now JavaScript and Haskell. Haskell specifically. This wouldn't work in Idris. But I feel like finally we've given a purpose to Haskell as an industry language, right? I feel like the breakthrough could be Idris can't do this. Why not choose Haskell? So we can see at the top we have what we're used to, and then down here we have tuples. Again, extremely useful for optimizing because we can unbox these tuples behind the scenes. We can ignore unital arguments for the category theorists in the room. And then down at the bottom, we can ignore loads of unital arguments because of composition. That's it. So the message I want to leave you with is that obviously a lot of this is scary. It's unfamiliar. We might never have heard of JavaScript before we stepped into this room. We've not looked at how it handles state, how it handles equality. We've not talked about the many forms of undefined and how we can or can't use it as a function. But we've seen something that hopefully has sort of tethered it back to our understanding. And so if you get nothing else from this talk, I want to leave you with this notion of independent types. You don't need this coupling. We want loosely coupled applications. I want you to think about distributed truth. Is Idris a good fit for large-scale distributed software? I'm not convinced. And finally, one thing we didn't really talk about is the notion of null and first-class failure. Undefined is something I wish I had time to talk about. Haskell actually early on made the correct decision of implementing it, and then due to peer pressure sort of ended up looking a bit more like Idris, but it was on a good track early on, and it all went a bit wrong. So thank you for bearing with me. If anyone needs support afterwards, I will be available. I'm on Twitter, etc., etc. Have a nice day.
Thanks, Tom. I feel like we've all got a bright future ahead with all the things you've been sharing with us.
Software isn't dead yet. It just smells funny.
Yeah. So if anyone has any questions about any of that mind-blowing set of topics, now is the time.
How dare you?
I don't know whether I'm allowed to break character now. Is there a category of microservices? So leading research from the Kubernetes developers would suggest that the most composable way to build an application is microservices. Presumably, the identity microservice would be the one that doesn't do anything, and that would be true of every microservice I've ever written. So yes, there would be a category instance, yes. Oh, God. Richard, I'm so sorry.
This isn't a bad one. So if decidable equality on types is impossible, how does Haskell do it?
That's a great question, and I know you know the answer. So Haskell has an interesting method of going about this, which is it kind of does have a notion of equality, but it's not very, I can't say good. It's not very clever. And what it has to say is, I can write a type family that checks two arguments are the same by saying, FAA. And if it knows that's right, if it has concretized those types to the point it can do the equality, it will say yes. If I say, Haskell does A equal B, and it doesn't know what either one of those are, it will say, I don't know, but the answer will be whatever the answer is to, does A equal B. And it sort of pats itself on the back and says, I've done my job, right? Go and figure out the answer. When you've done, tell me, and I'll tell you what you said. Which we call stuckness. And there's another gentleman over here that's done some terrible things with it. And I think that's how you get around it. The way I think it must be implemented in V8 and other JavaScript engines is you say, I can defer type errors until call sites and until I can resolve it. And so stuckness is kind of not a problem because everything I want to do with types is decidably equal. It's after they've been reduced and they're not dependent types or lambdas or whatever. So it works, but I think JavaScript takes a more kind of optimistic approach to decidable equality, which is to say it might work.
I'm sure you know JavaScript has the value not a number.
Yes.
And the type of not a number is number. Is Idris strictly powerful enough to express Zen concepts?
No. So the problem that Idris has in this area is it's a total language, right? We don't have general recursion, and I think a lot of the kind of Zen philosophies rely on this notion of the infinite, which is, so Idris has this notion of fuel, which is like, it's not infinite, but it's really big. And I think for true enlightenment, you need to go that step further. You need to trust that this program will never terminate.
So we need JavaScript.
I believe so, and I hope I've convinced you.
You have. Thank you.
Thank you.
Any more questions? Yes.
So much like many of the people in here, our team at work is porting our code from Idris to Idris 2.
Okay, yeah.
And it's not a substantial effort. But before we get all the way through, what advice would you give to convince our managers to let us port to JavaScript instead?
That's a tricky one. Obviously, JavaScript mainly exists in the academic community, and the notion of kind of package management in JavaScript is still being figured out. The notion of deployment. It doesn't have a great story for sharing code kind of on my front end and my back end. These are the kind of things we need to iron out. I would say the way you have to phrase it is, are they cowards, or do they want to live on the bleeding edge? You know, do they want to know what businesses will look like in 10 years when they're a decacorn, or are they happy just dissolving at Series B? Yeah. I think you have to phrase it as a threat. I think that's really, yeah.
Any more?
Otherwise, I've published this, I'm afraid, as a blog, but in the interest of being familiar to everyone, I can write this up as a paper and probably get it peer-reviewed and published by the end of the year.
Cool. Thank you very much, Tom, and let's give him a round of applause.
Thank you.